Hello, good day everyone. Like today we'll be dealing with capacitor. Today we will be dealing with what? Capacitor. So there's a question that will come to your mind, but please, this capacitor is a physics topic. So there's a question that will come to your mind, that what is a capacitor? A capacitor is a device for storing electrical what? Charges. I repeat, a capacitor is a device used for storing electrical what? Charges. And what are the functions of a capacitor? A capacitor is used to separate AC from DC. You know what's called AC and you know what's called DC. AC means alternative current, while DC means direct current. So a capacitor is used to separate alternating current from what? A direct current. Number two, it is used to control current in alternating what? Let's say in AC. The other one, I cannot say electric charges or energy is stored in a what? In a capacitor. Automatically, a capacitor is used to store what? Electric charges. So there are some things that always confuse students in exams. When we talk about arrangement of a capacitor, like the moment you hear arrangement of a capacitor, there are two types of arrangement. If you remember resistance very well, there are two types of what? Arrangement. We have the parallel arrangement and the series arrangement. So whenever you remember what is the parallel arrangement, what the moment you remember that, and the series, just think about, if you want to get it very well, just think about your resistor, which is your position of the flow of current in ohms. Just think about that. There are two types of arrangement there. You have the parallel and the series. So what I have to tell you now, if a current, let me just say this. If a current is flowing, this is a sign of a capacitor, please. This is a sign. The two must be equal. But if you see something like this, this is a cell, which is a battery. This is a capacitor, while this is a what? A battery. So if you see something going like this, a current moving, then you see one, you see this other one, you see something like this. Automatically, since the current is flowing, it will flow from here to get to a capacitor here, a capacitor. It will just be flowing on a straight line. It will flow like this on a straight line. So if the current flows like this, automatically all of them, they are arranged in what? In series. This is what we call series what? Arrangement. This is series arrangement of capacitor, whereby if you see something like this, then please don't mind my drawing. If you see a capacitor, a current moving this way, when you get to this particular point, you'll be seeing three different wires. One is moving this way, one is going here. Automatically, the current has to do what? To divert. It's going to move in different direction. So if the current is moving in this different direction, automatically this is what we know as a what? A parallel what? Arrangement. Because the current, it will get to a particular point, it will move it will be moving towards all these capacitor, to move to this side, move to this side, move here. Then at the end they come together here. This is what we call a parallel what? Arrangement. So there are some things that will come to your mind. In series arrangement, just for you to say, series arrangement is the reciprocal of a capacitor is equal to the reciprocal of C1 plus reciprocal, please, plus reciprocal of C2 T plus T. If they are 20, that's how you write it. Like this one now, you now say C is equals to capacitor is equals to C1 plus C2 plus C3 plus C4 plus let me say plus Cn. So what this means, it depends on the number of capacitor that are what, that are present. Please remember what capacitor means. Like I say, capacitor is a device for storing electrical what, charges. It's used to store electrical what, charges. So with what you are seeing here now, let me quickly give you a question. But before that, you should remember that the reciprocal, or the if you are looking for series, you use this formula. If you are calculating for parallel, you use this formula. Please. Unlike the other one, which is resistance. Like if it is resistance, the formula they have to interchange. So please note that. So like, let me pick a question. So this is a question, a why question in June 2006, WAS physics. So we are told that this question number 41, I mean, the equivalent capacitor of a 3 microfarad capacitor and 6 microfarad capacitor connected in parallel is A 2.0 microfarad, B 3.0 microfarad, C 4.5 microfarad, and D 9.0 microfarad. What you have to know now is that the connection is what, is a parallel connection, and we have two capacitors there. We have the 3 microfarad and the what, the 6 microfarad. So let's start our working. So let's start our working here. Let me say, if you remember the question, we have 3 microfarad and what, 6 microfarad. So, and they are connected in what, in parallel. They are connected in parallel, or they are connected parallelly. Then what you have to do now, you have to draw, let's draw our let me use our diagram. Let me say, let's represent our question with this diagram. Automatically, these are the two capacitors and they are connected in what, in parallel. This is 3 microfarad and here is 6 microfarad. Then we are told to calculate the equivalent what, capacitor. Please make sure that this capacitor, the two dots, the two lines, they must be equal. So if you are calculating, I said for parallel, the formula I use for parallel is C is equals to C1 plus C2. Why did I stop in 2? Because we only have two given parameter there, which is a 3 microfarad and 6 microfarad. Then if I continue, I'll say 3 microfarad plus 6 microfarad, or I can just throw away the signs, which is, I will just say 3 plus 6 microfarad. Automatically my answer will be what, 9 microfarad. So this 9 microfarad is our what, our answer. So let me bring on that question from our past question. So we are calculating this. Just read this question from 2001, question 34, was 2001. So what is the effective capacitance in the circuit? So if you look at this circuit now, we have 6 microfarad here, we have 6 microfarad here, we have 6 microfarad. This 100 volt. We are not looking at this part for now. Maybe in our next video we can do that. Then this question 34, they said we are to calculate the effective what, capacitance. So like the 36 now, that's when the volt can be applied. So let's start our working. So let me start my working. Automatically this 6 microfarad, then on that capacitance 6 microfarad, then this is my last capacitor. This is also 6 what, microfarad. There's no need of me bringing the volt. Let me just put my equivalent capacitor here. So we are calculating for the equivalent what, capacitor. Then remember, they are arranged what, in parallel. So since they are, in series. So since they are in series, connection, what I have to do now say the reciprocal of the effective capacitor is equal to the reciprocal of C1 plus the reciprocal of C2 plus the reciprocal of what? C3, which is 1 over C1. That's what it means. So the reciprocal of the effective capacity equals to 1 all over 6 plus 1 all over 6 plus 1 all over 6. Then the next thing that will come to your mind now, what's the SCM? The SCM is 6. 6 go to 6, 1. 1 times 1, 1. 6 go to 6, 1. 1 times 1, 1. 6 go to 6, it will give you 1. 1 times 1, 1. So automatically it will give you 3 all over 6. Then which is also the same thing as 1 all over 2, because if you cancel, give you 1, it give you 2. That should not be your answer. Remember, we are told to calculate for C, not the reciprocal of C. So if I'm told to calculate for C now, then I have to invert. Then C is equals to what? 2, which is I will change. I have to invert this part, both sides. Then I'll now say C is equals to what? 2. So that is our answer. And 2 will be the SI unit for it will be what? Microfarad. So please, like capacitance of a capacitor and let me just say a capacitor. If you are calculating capacitor, the first thing you have to look at is just know if it is arranged in series or in parallel. If it is arranged in series, you know what to do, and if they are arranged in parallel, you know what to do. Like for my formula, like from this part now, you notice that in series connection we use this formula, and the parallel connection we use this formula. So please, I'm advising you to subscribe if you have not done that before, and thanks for watching. God bless you.